Hi, this is Dr. Rajesh Kumar, Chief Scientist and Associate Professor from Nanobiomedicine Lab and Aquatic Nanotoxicology Unit. This is Cellular and Molecular Research Center, and I am in the Department of Pharmacology, Saveetha Dental College and Hospitals, CIMATS, Chennai. And in our lab, we are preparing all types of nanoparticles, nanocomposites, and novel nanoformations, and that and all used in the biomedical applications as well as the dental applications. In dental applications, we are preparing herbal and nano-based products like toothpaste, mouthwash, dental varnishes, and nano gels. Apart from by nanoparticles, we are coating with different types of implants also, and our nanobiomedicine lab associated with all the different divisions of dentistry like prosthodontics, endodontics, orthodontics, public health dentistry, and then periodontics. We have developed a lot of products in our lab itself, and we have more than 15 patents. That and all the product we are using now, clinical trials and all we are doing now. Apart from in our lab, we are offering some lab facilities like for the activities, antimicrobial activity, anti-inflammatory activity, antioxidant activity, and then anti-cancer activities. And in our lab, we have one unit like aquatic nanotoxicology unit. In that, we are doing zebrafish based studies. Zebrafish, you know that very sensitive studies, and we have developed that lab. And in India, we are the only dental college which associated with nano biomedicine lab, including aquatic nanotoxicology unit. In that, by using zebrafishes, we are doing many biomedical applications like hepatoprotective activity, anti-cancer activities, and anti-diabetic activity, wound healing activity. In that wound healing, our major specialization, and we have developed a new novel products for healing of wound by using nanocomposites and nanoformations, and that's all. And now we are move on to practical. What is the practical we are going to do, which is related to immunology based studies we are going to do now. Now we are going to lab for doing the practical that is related to immunology. This is Blue Lab, Molecular and Cellular Research Center. In that we have different types of disciplines such as Marine Biomedical and Research Laboratory headed by Dr. Shiv Perumal. This is Clinical Genetics Lab headed by Dr. Vijayashree Priyadashini. This is Molecular Biology Lab headed by Dr. Paramashivam. And we have one of the best sophisticated facility of room of refrigeration, and it is called as a cryo labs. Biochemistry and Molecular Biology Lab headed by Dr. Selvaraj Jayaraman. This is Aquatic Nanotoxicology Unit. See, we are doing research with zebrafishes, one of the important animal model, and then it is very sensitive research we are going to do for the biomedical applications. See this and all zebrafishes. This is RNA Biology Lab headed by Dr. Dorairaj Shekhar. This is Nanobiomedicine Lab and Aquatic Nanotoxicology Unit. See, already I told these are all some of my publications and some of my book chapters published in these books. This is Nanobiomedicine Lab and Aquatic Nanotoxicology Unit. Here only we are going to do our practicals for immunological assays. Today we are going to see cortisol immunoassay, the quantitative diagnostic analysis of cortisol by using kits. We know that nowadays a lot of kits are developed, and within 1 hour, 2 hours we will analyze COVID also, the positive, negative and antibody analysis and all we are doing. And today we are going to see how to analyze the cortisol by using immunoassay. For that we have a kit, and then the instrument we are going to use it is Elisa reader. Principle of the test: the TRG cortisol ELISA kit is solid phase enzyme linked immunosorbent assay, that is ELISA, you know that, based on the principle of competitive binding is a major part of this. The microliter wells are coated with monoclonal antibody directed towards an antigenic site on the cortisol molecule. Endogenous cortisol of a patient sample completes with the cortisol horseradish peroxidase conjugate for binding to the coated antibody. After incubation, the unbound conjugate is washed off. the amount of bound peroxidase conjugate is inversely proportional to the concentration of the cortisol in sample. After the addition of the substrate solution, the intensity of the color developed is inversely proportional to the concentration of the cortisol in the patient sample. Today we are going to check cortisol analysis. The novel thing of this immunoassays, actually people will do cortisol analysis by using serum samples only. Today we are going to see that salivary cortisol level in the samples. The materials available in the kit is, the reagents and the materials provided in the kits are, first one, microliter wells. This is a 96 well plate. In that 7 vials are there. First one 0, 20, 50, 100, 200, 400 and 800. The concentration is this and all the nanograms per ml. And third one is enzyme conjugate. This is a cortisol conjugated to horseradish peroxidases, contains a non-mercury preservative. And fourth one is substrate solution. Substrate solution contains tetramethylbenzidine. And fifth one is stop solution. Stop solution is a 0.5 molar of H2SO4. And sixth one is wash solution. Wash solution is actually 40x concentrated, that we will dilute and use it for our study. Final one is the wash solution. Wash solution is a 30x concentration solution. So we will dilute it for a 1x concentration and use it for our study. Then we will move on to analysis of corticosterol by saliva samples. Now we will start the cortisol analysis. This is a 96 well plate. Always before starting the procedures, we have to make the protocol. You have to read the instructions carefully. You read it, and you have to write it in your notebook. In your handwritten, we have to write the protocol. Then only the procedures will always in your mind. Then easy to do this, and for explaining others also it will be good for us. And then now we will going to add standard, control and samples. Today we will take 3 samples for our study, and the sample and patient details and all we have it in our notebook. First, this is a 96 well plate. You can see this. So many people know that what is 96 well plate. Totally 96 wells will be there. At a time we will do more than 20 or 30 samples if we will do it as a triplicate. First we will add standard. This is a 20 ml of standard we are going to add. Already we told in standard itself 7 different concentrations are there. First one 0. First one 0. This is a 20 ml we are going to add the sample. See this. A1 is 0. Then B1 is 20. Third one is 50. Fourth one is 100. Fifth one is 200. The fifth one is 200 ml. The sixth one is 400 ml. The final one, last one of standard is 800 ml we are going to add. The next group is control we are going to use. Control also the same 20 ml only we are going to add. Let's take the control. In the Elisa plates, we will add the samples continuously, but for the demonstration purpose, especially you have to understand what we are doing. So we are doing it as a control, as a second belt. Like this we will plan and do, because it is easy to understand the color changes and all. To understanding purpose only, I will add this in a second row, second column we will add. This is control. Control we will add 2 times also. Just to understanding of the color changes, we will add 2 times. 2 times, or we will do 3 times also. Okay. See, just like a triplicate we will do. Control in the column 2, I have added the same sample in the 3 times in the samples. Okay. Yeah, the next one is sample we are going to take. Okay. Already you have noted the names and informations in your notebook. Yes. Yeah. Today we are going to check 3 samples with 3 different concentration, not the concentration, and triplicate we are going to do. First sample is Shermley. To open. See, already I told we are going to triplicate this. So first one is standard, second one is control, and third one is patient sample. Patient sample also the same, 200 ml only we are going to use it. And this is third column, 1, 2, 3. So and the next sample is Sai Ganesh, and we have the list of patients' name. So it will be considered for the 4th column we will add. 4th column, 1, 2, 3. Close it. And the third patient, the patient name is Hari Prasad. This one we will add it in the 5th column. 5th column, 1, 2, 3. So triplicate we are going to do, already I told. Now we are going to add enzyme conjugate in the each wells. 200 ml of enzyme conjugate is we are going to add it with standard, control, and 3 different samples. We will add the enzyme conjugate in the 200 ml of enzyme conjugate is we are going to add it in the all the samples, including standard, control, and then 3 different patient samples. 200 ml. Now you can see. First one standard we finished. Next is the control. Control already I told that control also we are going to do triplicate. Control is over, and from the third one it is a sample 1. And you already noted that informations of the patient name is very important. First we have to write the name, and second one is gender, male or female, and now we are going to check cortisol. Nowadays we are going to check COVID positive or negative, and they did the first dose or second dose. That information and all you have to write it in your notebook. Okay. And both the first and second patients are did their first dose of injections for COVID. Okay. Because to make the graph and all, the information is very must. That second sample we are adding enzyme conjugate, and now we are going to add third sample. Okay. Now we have added enzyme conjugate in the all the samples. Okay. See, close it. This procedures and all adding of enzyme conjugate, we have to finish it in 10 to 20 seconds. We have to finish. After that, we will add all the samples in the wells. You know that already I told. What is that first one? First one is standard, second one is control, third one is patient 1, patient 2, patient 3. Now we have added enzyme conjugate in the all the samples. I told that first one is standard of 7 different concentration of standard, and the second one is control, third one is patient 1, this one is patient 2, patient 3. We have added, and just we will keep it here for 1 hour, 60 minutes. We are going to keep it without disturbing this plates. Just we will keep it. Just you have to close it, and without disturbance it will be kept for 60 minutes. Already we told the next step of this is washing. So in that first slide itself I told we are going to prepare wash solution, because this one is a wash solution. This is a highly concentrated wash solution. If you will add directly, means what will happen? That enzyme bound proteins will get erased. So we will use this diluted form of this wash solution, and that it was clearly mentioned that how much this is a 30 ml of wash solution they have provided, and in that book itself they have mentioned this was concentrated. So we will make it as diluted 40x. If it is a 40x solution, means how we will dilute it? 1 ml in 39 ml of distilled water. If we will mix, we will get the wash solution. Now we are going to prepare the wash solution in the beaker. Pipette. See, this is a 5 ml pipette. In that we are going to prepare the wash solution. See, I do 5 ml. In that we will add 5 ml of the concentrated solution. 5 ml. And anyway, for the studies and all, we need 400 ml of wash solution. So I am going to prepare 400 ml. So I told in that 1 ml, if we will mix it with 39 ml, then the 40x concentration will become 1x concentration. So if we will add 10 ml of wash solution, means how much distilled water we are going to add? We are going to add 390 ml of distilled water in this, and that 390 ml of distilled water will mix, then it will become 400. That is a diluted 1x concentration of wash solution. We are going to use it for the study. Please provide distilled water. See, handling of measuring cylinder, handling of adding of solutions and all, it is an art in the chemistry labs. See, you can see always, you can look this how much concentration. If you want 50 ml of concentration, means Always we will keep the solution like this. Then only we will analyze. See, we are going to add 390 ml. So this is a 100 ml measuring cylinder. Always solution like this. This is 100. Exactly 100. I am going to add it in the solution. Always we will add the solution. Mixing of solution is in the corner only. Always we like to add 100. See, we want 400 ml already, I told you, no, so we will change it into another one fast. See, this will be useful for the mixing also. Third one. This is third one. Then 300 ml. Then remaining is 90 ml. Yes, 90 ml we are going to add it in the solution with the this. See, 90 ml. I'm going to add it. This already I told 10 ml of concentrated wash solution plus 390 ml of distilled water. We have to mix it gently for the preparation of this 1x wash solution. See, in that chemistry labs, the calculation is very important. Okay, each and every chemical we have to calculate it. Addition, mixing and all, we have to do it properly and neatly. We have to mix it. Always we will make gentle mixing, or else we will use magnetic stirrer also for the mixing of the solutions. Mix it. See that incubation of the solution is going on. Within 5 minutes it's going to finish. After 5 minutes we are going to add wash solution. Then the wash solution is ready. This one right. Yeah, the next step of our study is washing. Washing by using wash solution we are going to use. So in that 60 minutes gap we have prepared our washing solution. That in each wells we are going to add 400 ml of wash solution. 3 times we are going to wash. Give me that. This one is 400 ml. We are going to take the wash solution. This is a prepared wash solution. We are going to add it in this. Wash it. See, in the each wells we are going to add wash solution. 3 times we have finished the washing, and next we are going to add under removal of substrate solution. See, this is the substrate solution, and we are going to add under removal in each wells. We are going to add it. Okay, then give me under removal. Under the removal we are going to add it to this. Already I told that first one is a 7 different concentration of standard, and the second one is control, and third one is patient 1, fourth one is patient 2, and fifth one is patient 3. Okay. After the addition of a substrate solution in this, we are going to keep this 15 minutes in a room temperature. Just we have to close it. We will keep this for 15 minutes incubation, and after 15 minutes we will stop the next step of our study. This is the Elisa reader, and the final results we are going to analyze by using this Elisa reader, and this is specially used for the 96 well plate readers. Cortisol we are going to analyze. Cortisol, and today's date we also will mention it here, like 8. Okay. Okay, save it. And we are going to analyze at 450 nanometer. This is exact absorbance we are going to analyze by using this one. And already I told in that we took 4 wells. Okay, 4 columns, 1, 2, 3, 4, 5. Yeah. We are going to analyze, already I told that 1, 2, 3, 4, 5. 5 columns we are going to use. The column is 1, 2, 3, 4, 5, and A, B, C, D, E, F, G, H up to H it will be there. And first one is standard, and first in that first well we are going to analyze 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Yeah, 1 to 12 in general. Okay. And our analysis is 42, 28, okay. And what are the things we are going to analyze? 1, 2, 3, 4, 5, 6, 7. Okay, and the next one is control, 1, 2, 3. 1, okay, 3, 4, another one. And yes, and each one we have to analyze 3, 3. 1, 1. And one more. So totally first one standard, second one is control, third one is patient 1, patient 2, patient 3 we are going to analyze. Okay, our incubation time is over, and final thing we are going to add it here. See, this color change was happened in this blue color solution. So it indicates some reaction has happened, and that our sample as well as the control standard is mixed with that substrate solution and made some color changes. So the reaction has happened. So what to do? Well, next step on, we would like to stop the reaction. To stop the reaction, what we will do? We will add stop solution. So under removal of stop solution is we are going to add it with all the wells. So this is the stop solution we are going to add this reaction. Okay, open it. See this, while you are adding the stop solution, the color change, how much color change will be there in this. And then we will cancel this. Third one, the blue color turned into yellow color, which indicates that stop solution working properly and it stopped that reactions. And the third one is patient 1. Patient 1. Patient 2 finished. The third one is patient 3. The triplicate values. So just before adding this, just you can see this is a substrate added one, that remaining and all, that stop solution added. See, while we are adding this, the color turned into yellow color. The stop solution did its activity properly, and just will mix it and then close. In this, all the practical procedures will be over. Okay, we have started with what we have started with, standard control and all added, and then we have added the enzyme conjugate, then we have washed, and third one we have added substrate solution. The substrate solution closely that reacts with that samples and all, and then we have added stop solution. Up to this, all the reaction will be over. And what is the next point? Next, we are going to analyze these values. We want exact absorbance values. We are going to analyze by using this Elisa reader. Keep it. In that the reaction mixture, the 96 will plate, we are keep it in that Elisa reader, and you know that already we have mentioned that 450 nanometer we are going to analyze it. Okay, that reaction is finished, and we kept it that 96 well plate in the Elisa reader, and already we fixed the reading. We will take the reading at 450 nanometer we are going to take, and then the reaction is finished. So we will close, we will start the Elisa reader study. In that Elisa reader, at the time already I told, up to 96 samples we will analyze by using this instrument. See, we have received this values. Okay, 388 to 0.237, 255, 2.242, 0.574. This is the readings, and we have the printing option also. So we don't want to waste the paper, and it will be useful for our environment. Just we will take the photo of this values, and we will enter it in Excel file, and we will make it the values we will enter, and we will give the results to the sample patients or whatever. Take photo. Mobile phone. Take your mobile phone and take the photo of those values. Today we did the in vitro diagnostic study of cortisol by using samples. What we have used is saliva, and what are all the steps we did is you observed that, and based on that only in that kits, Elisa kits, nowadays a lot of kits are developed to analyze all the biochemical parameters, such as already I told that from COVID to, and biochemical parameters like enzymes and all we analyze by using Elisa reader. And then for all those things the procedure is same. Just we will add the substrate, we will add the solution, and then we will add the stop solution, and we will took the absorbance in the equipments. These are all the simple procedures. We have to read the procedures carefully. You can read it, and then you have to write your own handwritten, you can write your protocols. Then you can proceed for your studies. That's all. Today's cortisol diagnostic analysis is over. Thank you so much for this opportunity. Thank you all.